In this podcast, we're going to solve 3 problems involving a rectangle where our sides are changing. So here we have our changing rectangle. The length L of a rectangle is increasing at a rate of 4 centimeters per second, while the width W is decreasing at a rate of 4 centimeters per second. So if the width is decreasing, that's going to be a negative number. So dW dt, there we go, is going to be negative 4 centimeters per second. So be looking for words like decreasing, shrinking, anything getting smaller, anything that indicates that your object is getting smaller means that your rate of change is going to be negative. Okay? So when the length is 5 centimeters and the width is 8 centimeters, we want to find the rate of change of the area, the perimeter, and the lengths of the diagonal. Determine which of these is increasing, decreasing, or constant. Okay? All right, so let's take a look at our first one here. So first of all, we're going to find the rate of change of the area, the one that's underlined in this problem here. All right, so always you want to draw a picture. Here I have a picture of a rectangle. The length of the rectangle is 5 centimeters. The width is 8 centimeters. Right, and the length is the rate of change in the length, the dl dt, is increasing, and that is 4 centimeters per second. The width is decreasing. And the width is since the width is decreasing, it's going to be negative. So dW dt is negative 4 centimeters per second. So our second step, after we have our diagram labeled and all our variables figured out, is we want to figure out which of our formulas, what equation would link all of these together, what links area, length, and width. And of course, that's going to be an area formula here for a rectangle. Okay? So we have area equals length times width. We have 2 variables that are being multiplied. It's going to be the product rule. The derivative of A with respect to time would be dA dt equals, okay, so remember your product rule. It's the first times the derivative of the second plus the second times the derivative of the first, okay, is the product rule. Oops. New way to spell product. Product rule. All right, so dA dt equals the first L. The derivative of W would be dW dt plus the second W times the derivative of the first, which is dL dt. All right, we already have our what we're looking for isolated. Right? We have our unknown, the dA dt, isolated. And so now all we have to do is plug in the value. So remember, we take the derivative first, and then we plug in the values. So L is 5, and dW dt is negative 4, plus W is 8, and dL dt is 4. And so that's going to give us 5 times negative 4 being negative 20, plus 32 is 12 centimeters per second. Okay? And actually, that should be 12 centimeters squared, per second. Area is measured in square units. So here, since dA dt is positive, our area is increasing. Okay? So the area of the rectangle is increasing as our length and width are changing. Okay, so here's our first one. Let's take a look at the second problem about the perimeter. Okay, so same problem, except now we're finding the perimeter. So none of the values have changed from the problem we just did. The length is still 5 centimeters. The width is 8 centimeters. The rate of change in the length, dL dt, is positive 4 centimeters per second. And the dW dt is negative 4 centimeters per second. All right, so the equation that links our two variables, or three variables, perimeter, length, and width, of course, is the perimeter formula for a rectangle. Find the perimeter of a rectangle. The length, the opposite sides are equal to one another. So, on either side, the lengths are equal, and on either side, the widths are equal. So now we can take the derivative of the perimeter formula. And of course, what we're looking for is the rate of change in the perimeter. So we're looking for dpdt. Right? So we'll take the derivative here. Derivative of p is going to be dp dt. Okay, the derivative of 2l, 2 is a constant, derivative of, and it's a coefficient constant, so of course that's still going to be there. And the derivative of L would be dl dt. So the derivative of 2L is 2L dt. The derivative of 2W is 2 dW dt. Let's move this a little bit. There we go. All right, so now we've taken the derivative, we can plug in. We already have dp/dt isolated. That's what we're looking for. So we have dp dt equals 2. dl dt is 4 plus 2, and dw dt is negative 4. Well, that's going to give us dp dt is 8 minus 8, so that's going to be 0. There is no change in the perimeter. One side is getting larger, and the other side is getting smaller at the same rate. So our perimeter here is constant. There's no change in our perimeter. The area is changing, the area is increasing, the perimeter is not. Okay. All right, let's look at the third problem. All right, so the length of a rectangle is increasing. Same scenario at 4 centimeters per second. Width is decreasing at a rate of 4 centimeters per second. When the length is 5 centimeters and the width is 8, we want to find the rate of change in the lengths of the diagonal. So we're looking to solve for dd dt, okay? Change in the diagonal. So if you remember from geometry, rectangle has a right angle there. So W, L, and D form a right triangle. So one formula that would relate the length, the width, and the diagonal, all three sides, is the perimeter for the Pythagorean theorem. Pythagorean theorem formula. So Pythagorean theorem here, because this is a right triangle, will relate all three sides. All three are changing, right? Length is changing, width is changing, and if length and width change, the diagonal may change as well. So no constants here. All right, so we're going to take the derivative of d squared equals L squared plus W squared. Derivative of d squared would be 2d dd dt equals derivative of L squared would be 2L dl dt and 2W dW dt. All right, so now we want to isolate our dd dt. So everybody's got a coefficient of 2. We can just divide by 2. So that's going to give us d dd dt equals L dl dt plus W dW dt. Right, so now we'll just divide by D, and I realize we never did find out what D is. Okay, we have everything else, and we're looking for d dt, but we never did find d. Well, that's just an algebra problem. Just going to use Pythagorean theorem, so divide everything by d here. So we just use Pythagorean theorem over here to find out what d is so that we can replace. All right, so length here is 5, width is 8, so that gives us d squared equals 5 squared plus 8 squared. 5 squared would be 25 plus 64, it's going to be 89. And that means d is the square root of 89. That's a prime number. That's not going to simplify at all. So let's just leave it like that. Okay? All right, so now we just got to plug in here. Oops. I don't have enough space. I almost pulled my microphone out. Need to get a little more space. There we go. I'll move this down a little bit. All right, so d dt is length, if you can see it up there, is 5. So we have 5. dl dt is 4. Plus w is 8. And dw dt is negative 4. All divided by the square root of 89. So that's going to be d dt is 20 minus 32 all over the square root of 89. So that's going to be, I'll put it over here, negative 12 over the square root of 89. And if we probably just simplify that radical, or get that radical out of the denominator, we should rationalize. Negative 12 square roots of 89 over 89. That'd be the exact answer. And we should have a unit of measure there. This was centimeters. And that's centimeters per second. Oops. Just dropped a pen. Centimeters per second. Boy, you can't really see that unit of measure there, can you? Well, just know it's there. So now length of our diagonals are decreasing because dd dt is negative. So the diagonal is decreasing as the width is decreasing. And there's how to solve all 3 of those changing rectangle problems. I hope that all made sense to you. And really all we did was use a couple formulas related to a right triangle and a rectangle. Have a good day. Bye.